So essentially, this is image sensing. There are a lot of array of sensors as we talk about. We also talked about the spatial sampling. We don't want too much of light being collected from this area. We want either this area is small, right? For example, within the 1 pixel, you can have 4 pixels, and then you can collect light from this, call it as 1 pixel. Collect light from this, call it as another pixel. So, for example, this is the image. One image element is basically this particular region, right? U comma V. So the intensity value is some value. This is all shown here, right? So I'm not going to the details, which of course we did again there. Now, we earlier told you there is something called spatial resolution as well as intensity resolution. So in a typical spatial resolution, the size of the image pixels keeps decreasing. Therefore, you see the smaller sized image. So in a typical smaller sized image, when it's stretched, so this is zoomed version. So you actually losing the actual shape and beauty of the petals that are there, which are getting distorted. So similarly, the intensity resolution, spatial resolution, intensity resolution. You can have number of bits for intensity. You can have 8 bits or 18 bits. 16 bits are very standard. This is very standard. So we'll have 256 levels, and then the values are 8-bit values goes in the range. So a lot of levels, then you get a very high density pictures, right? So as you see, there are only 2 levels. 2 levels, it's only either a white pixel value or a dark pixel value. White pixel value means 255, dark pixel value means 0. So if you can put pixel values, for example, somebody can write 000 here, suddenly you have a 255. So somebody can interpret values. So this is only 2 levels. Okay, it requires either 0-bit or a 1-bit, 2 levels, right? So therefore, the number of bits per pixel is 1 bit per pixel, either 0-bit or a 1-bit. So the number of bits is 1 bit per pixel. Similarly, here if you have 4 levels, you combination of 0, 1, 0, 0, 1, 0, and for example 1, 1. Okay, 4 values are only used to represent. So 1, 2, 3, 4, 0, 1, 2, 3 or something. So you can have only 2 bits per pixel. There are 4 levels. So similarly, number of levels basically talks about how this images will get represented. So okay, now resolution is basically important because, for example, you see a very high resolution image on this side, a poor resolution image on the side. Though there is a car here, the number plate is not seen. However, it's very clearly seen. One can read from distance. So resolution helps you to understand image information better. So you should have better intensity resolution. You also have a good spatial resolution. So you have high detail. This is why I call high detail means there are too many people. From here you will be able to understand, for example, the number of people who are present. This is all in a crowd sensing kind of scenario, right? So you're trying to understand from the crowd behavior or whatever it is. So you have to listen to a lot of information that is present. A lot of information is what is called as a high detailed information, low detailed information. Nothing much changes from one pixel to other pixel. So low, okay. So medium detail because this contains certain background information, the foreground information.